Welcome to the first episode of our series on quantum physics. In this episode, we will introduce you to the basics of quantum physics and how it differs from classical physics. We will explore some of the strange and mysterious phenomena that quantum mechanics describes, such as wave-particle duality and superposition. To understand quantum mechanics, we first need to understand how it differs from classical mechanics. Classical mechanics describes the behavior of macroscopic objects, like planets and cars moving at low speeds, and is based on the laws of motion formulated by Sir Isaac Newton in the 17th century. However, when we look at particles on a very small scale, like atoms and subatomic particles, classical mechanics falls short. This is where quantum mechanics comes to the rescue. Quantum mechanics was developed in the early 20th century. According to quantum mechanics, the behavior of subatomic particles cannot be predicted with certainty. Instead, it is described in terms of probabilities. The act of observing or measuring a subatomic particle can change its behavior, a concept known as wave-particle duality. One of the fundamental concepts of quantum mechanics is wave-particle duality. This means that particles, such as electrons and photons, can exhibit both wave-like and particle-like behavior. In some experiments, they behave like waves, showing interference patterns and diffraction effects, much like waves of light or sound. While in others, they behave like discrete particles, showing well-defined position and momentum. Now let's take a look at this from a mathematical perspective. The wave-like behavior of particles is described by their wave function, which is a mathematical function that represents the probability amplitude of finding the particle at a particular location. While the particle-like behavior of particles is described by their position and momentum. As we will see in detail in the series, wave-particle duality has important implications for the interpretation of quantum mechanics and the development of technologies that rely on the behavior of subatomic particles, such as quantum computers. Another key concept of quantum mechanics is superposition. This refers to the ability of particles to exist in multiple states simultaneously, otherwise known as quantum states. For example, an electron can exist in a superposition of two different energy states, which gives it the potential to perform multiple tasks at once. When a measurement is made on the particle, the superposition collapses into one of the possible states, with a probability determined by its wave function. Superposition has important implications for quantum computing, where multiple quantum bits or qubits can exist in a superposed state, allowing for exponentially faster computations than classical computers. Later in the series, we will introduce the uncertainty principle, which is a fundamental concept of quantum mechanics. This principle states that it is impossible to simultaneously know a pair of physical quantities with absolute precision. The more precisely we know one of these properties, the less precisely we can know the other. These pairs include position and momentum, energy and time, and angular momentum in different directions. Practically, the uncertainty principle has important applications in various fields, such as quantum cryptography, quantum computing, and precision measurement. Also playing a role in the development of new technologies such as atomic clocks and quantum sensors. Quantum mechanics is a fascinating and mind-bending field that has revolutionized our understanding of the nature of reality. In this episode, we have introduced you to the basics of quantum mechanics, including wave-particle duality, superposition, and the uncertainty principle. Join us next time as we explore the famous double-slit experiment and its implications for quantum mechanics.